So today we're taking a look at this first science passage. Now the science section of the ACT, you answer 40 questions in 35 minutes. So you have to be answering a little more than one question a minute. Along with that, though, you do have to be reading and interpreting data. So the biggest tip for the science section is to not get caught up trying to read and interpret everything before you get to the questions. The best thing to do is to look at the little intro paragraph that kind of explains what you'll be looking at, and then go to the questions. Read the question. It will often reference a specific graph that you can go look at to answer the question. Now, the reason for this is when you're looking at a graph or some data, there is too many questions that they could ask for you to actually be able to look at it, retain information, and answer the question. For instance, looking just at this graph here, they could ask, which type of food has the biggest drop between 16 and 24 hours? And you could compare the differences between them. They could ask, which food reached the 160 mark first? And you would say, oh, that's peanuts. It dropped below 160 before any of the other ones. They could ask at which hour was the most food eaten. They could ask so many things. And because of that, it's very difficult, and part of the reason they try to catch students with time in the science section is having you try to look at these things and understand them and be like, okay, well, what does this mean? And you start analyzing and thinking about stuff that doesn't actually matter for what the questions say. So the recommended thing, what I would do when you get to a passage, is to read the intro, maybe read if there's a little explanation of some of the figures and graphs, so you have an idea of what's going on and can answer accordingly. So this one here, this passage says, a study was conducted to examine whether female Patella germanica, a species of cockroach. Side note, in the science section, they will often have scientific words or vocabulary that they'll put in italics like this. Most of the time they don't matter, and they will give you the definition. So you don't have to know a bunch of the science words. They will tell you what they are, which is nice. So it says, this species of cockroach prefers to eat cat food, cheese, ham, or peanuts. First, 200 milligrams of each of these four foods was separately placed into a single box. Then adult female B. germanica were added to the box. Figure 1 show how the mass in milligrams of each food in the box changed over time after the addition of B. germanica. Table 1 shows the percent by mass of carbohydrates, lipids, proteins, and water respectively present in each of the four foods tested in the study. So we're looking at what does this cockroach like to eat. So let's go to question 1. According to figure 1, the mass of cheese remaining at 4 hours was closest to which of the following value? So now I know I'm looking at cheese, which is the white bars here, at 4 hours. So we come to the 4-hour mark. And cheese, it looks like that is right about 185. Let's see. Nice and easy. Suppose a company wants to use food as a bait in a trap designed to capture female B. germanica. Based on figure 1, which of the four foods should the company place in the trap to maximize the chance of capturing female B. germanica? Okay, so if you're trying to lay a trap, get the thing to eat food, you probably want it to be the thing that it likes the most. Therefore, we come over here, we say, hey, after 28 hours, the thing that got eaten the most was peanuts. J. So that's our best answer there. Consider the four foods in order of the percent by mass of proteins from lowest to highest. From food to food, as the percent by mass of proteins increased, the mass of food remaining at 28 hours did what? So we're looking at what's the trend as the protein percent goes up in the food. So this one, we finally get to go use table 1, and we're able to look at the proteins here. Now this is nice. We see that when you go from cat food to cheese to ham to peanuts, The amount of protein is increasing as we go through those four. And looking at the final results of our graph over here, we can see that of those four foods, cat food, cheese, ham, peanuts, the amount left decreases. There's less of it the more protein you get. Cat food has the least amount of protein. There's the most food left at 28 hours. There's still like 168 milligrams, whereas the one with the most protein, peanuts, has the least amount of food left. So we can come down here and say this is decreased only. Okay, number 4. Now, as you may have noticed, right, we didn't need any of this information so far in the table. So this, again, is the trick they try to get you to fall into of trying to understand everything and look at everything when you don't actually need it all to answer the question. So number 4, consider the statement, the B. germanica ate the food between 0 hour and 4 hours, between 4 hours and 16 hours, between 16 hours and 24 hours, and between 24 and 28 hours. This statement is consistent with the data in figure 1 for how many of the 4 foods. So basically, did they eat food at every interval? So let's go up to figure 1. We can see for the black bar here, it drops at every interval, even though it's not a ton. The white bar also drops at every interval. The gray bar is dropping consistently, and the stripe bar is dropping. So all 4 of them are being eaten at each interval. Number 5. A student predicted that the B. germanica would eat less cat food than ham by the end of the study. Do the data in figure 1 support this prediction? Yes. So let's take a look at the 28 here so we can see they did not eat very much cat food. It only dropped from 200 to about 167, whereas ham dropped from 200 milligrams all the way to about 110. So there's a lot more of it eaten. So the answer is yes. So it's going to be either A or B here. A says yes, at 28 hours, the mass of cat food remaining was about 55 milligrams greater than the mass of ham remaining. Okay, so let's take a look what that difference is. So 165 down to 110, that's a difference of about 55 milligrams, which is indeed the answer. The other one says the difference would be 95 milligrams, which is not true. It didn't eat quite that much difference, so it's A. And then our last question here, based on table 1, when 200 milligrams of each of the 4 foods was placed in the box, water accounted for more than 100 milligrams of the mass of which food? Okay, so this one doesn't tell us exactly which part of the data to reference. However, table 1 tells us the percent of the food is made up by what different things. This question here is saying if I have 200 milligrams, when will water be more than 100 milligrams of it? 100 milligrams is 50% of 200. So it's saying in which of the foods is water more than 50%? So we can come up here and say that water is more than 50% for cat food and for ham. So we can come down here, see that there is indeed an option G right here, where cat food and ham are the ones that have more than 50% water.